Objectives for this lesson are focusing on graphs. So plot and interpret a speed time graph and a distance time graph. Also, we are going to look at, we're going to recognize from the shape of the speed time graph when a body is at rest, moving with constant speed, and moving with changing speed. This is an area that many of my students really struggle with because it is just lines on a graph. And they really need a way to visualize. Most people need a way to visualize this. Okay, the classic way to visualize these graphs is to basically just sketch out what's happening. So in the background here, I have a video, and he's just drawing this tank, 50 meters for 10 seconds. Okay? Then actually graphing it on the graph so you can see what it looks like on the graph. Um, then we have, the other aspects, slowing down, speeding up. He's graphing it by hand while he's drawing pictures, and that's kind of the classic way of doing it. But by using the Makerspace, I think it gives the kids more of a hands-on uh, visualization of what's going on, and they're able to actually see. Okay, this car that we're using or this marble we're using is speeding up. It's slowing down, it's stopping. This is what it looks like on the graph when it does that. Another aspect of doing this Makerspace lab is not being able, many schools don't have the equipment. So if you see in the picture here, this is a special lab tool where you can measure angles. It's got weights, it's got rollers. Um, it's made for this type of experiment. And if your lab has something like this, that's amazing. But the only labs I've seen these actual tools in are in university labs. None of the schools that I've taught in have had something like this. So this is also a way to recreate a piece of lab equipment that you just might not have access to. The learning outcome for this will be that the students will be able to model the motion of graphs using Makerspace tools and materials, including recognizing when a body is at rest, moving with constant speed, and moving with changing speed. The materials needed for your Makerspace are very simple. You need a whiteboard and markers for planning, examples of your motion graphs, and cardboard, scissors, tape, anything you might need to build ramps, books, boards, whatever you can come up with. I was unable to actually perform this lesson this week. We were having final exams, so I really didn't have class with my students. So I've included some videos of students that are doing similar type of things with Makerspace, doing motion, speed, time, um, just to kind of give you an idea of what it would look like in a classroom setting. Okay, now for the lesson itself. Um, as always, you want to begin by reviewing the concepts of speed and time and motions graphs. They should be somewhat familiar with them before you start this task. Um, Then you're going to introduce the idea of using the makerspace. Kind of go over what is available for them, what they have to use, and kind of what's expected of them. Explain to the students that using the makerspace tools and materials to create physical models of motion graphs. Then you want to model for them. Create a simple model of a motion graph using the same makerspace tools that they have available. Example of this, just making a marble run that has maybe multiple levels, a ramp, a flat surface, and another ramp, just to show how it goes along with a motion graph. Give them a few examples to help them get started. Um, then you give them time to work independently in pairs and groups, however you want to do this, to create their makerspace models. Then once everybody has their models made, this lesson could go over a couple of days, and you can have a presentation at the end. Share their models, explain what they represent, encourage them to identify when an object's at rest, moving with a constant speed, or moving with changing speed. Then you can provide additional examples for kids who need more support. Maybe they can do less aspects of the graph, maybe a 2-part graph instead of a 3 or 4-part graph. Then you want to end the lesson by summarizing the key points, checking for understanding. To differentiate this lesson, there are a lot of different ways you can go. For students who need more support, you can always provide additional examples, guided practice. You can also make them model simpler graphs. Just make it a little bit easier for them to create what they need to create. For the students who have a good grasp of this already and they want to do a more advanced project, you can have them create more complex models with multiple movements or scenarios. And this way, it gets everybody involved. You can also work on your pairing. You can pair strong students with a weaker student. That way, they can create together. This is a very, very easy lesson to differentiate, and there should be something for everybody in this area.